Welcome, guys. I'm very happy to be broadcasting live presentation on working space about electrical equipment. And for this presentation, I really bringing you, my own perspective about electrical equipment being installed in a certain definite space, and that to include, the working space, the clear space, illumination of the space, dedicated equipment space, and electrical equipment room or enclosure. All right, so this is part of the article in the National Electrical Code, that is 110.26. All right, so we're just going to give you a brief, a general overview of electrical equipment about working space, and that will explain how we go about carrying out installation of electrical equipment as regards, a particular space. All right, so I'm just going to walk through with you instructively how we go about this particular installation. I welcome everyone who is watching this presentation and who is about to see it in the future. All right, so when it comes to working space, we establish, our rules, our grounds, which want an equipment to be installed to protect personnel who work in vicinity of the equipment without jeopardizing safety. So we maintain working space because normally we have equipment operating at high voltage. That may include 600 voltage or more. And typically our examiners will go in and look at equipment, inspect equipment, and provide servicing. All right, this may include panel boards, switchboards, breaker, control centers, air conditioning unit, and so forth. All right, so we have to maintain a distance for those equipment we want to maintain. All right, so that includes the dimension of working space. All right, so when it comes to the dimensions of working space, we're looking at the working space depths, looking at the height of the working space, looking at the width of the working space. All right, so we have to maintain a particular dimension. Say, for example, I need to be in that particular space. I must be able to fit within that space, knowing my height. And say, for example, I need to have a minimum space, whether width, to be standing in that space. All right, so we look at the height, the depths, and the width. All right, so the depth of the working space shall be maintained at the distance in the direction of the live parts. So in terms of voltage level, we have 150 volts. We're supposed to maintain at least 3 feet, 150 to 600 volts. It will follow 3 feet, 3.5 feet, or 6 or 4 feet. All right, so the higher the voltage level is the greater the space that we need to maintain for those equipment. All right, so let's look at it once again, the minimum clearance condition requirement for the working space. So this include condition 1, expose live parts on one side of the working space with 3 feet voltage level 0 to 50 volts or 151 to 600 volts. All right, and condition 2, which is condition which requires live parts on one side of the working space and a ground part on the other side of the working space. Ground could mean metal, or it could be any grounded like concrete, in particular, that is directly connected to ground. Condition 3, which requires both life parts on both sides of the working space between 0 to 150 volts or 151 to 600 volts. All right, so 150 would requires 3 feet to be maintained, or 600 volts, or anything greater than 151 volts, or 600 volts minimum. We should have at least 4 feet to maintain between two live parts of equipment that maintain. So two equipment standing next beside each other. All right, you're supposed to have a distance to be maintained at least 4 feet when it's a voltage level greater than, or say greater than 151 volts or less than 600 volts. All right, so this diagram also gives us an illustration. Right, so that goes to explain what I was talking about. Right, so the higher the voltage level, you should maintain a greater distance. All right, so the width of the working space now, that is the space before the equipment you're about to maintain, and that requires a minimum of 30 inches or the width of that equipment. All right, so whether it want to be a small panel or a switchboard, you're supposed to have enough space before that equipment. So the bigger the equipment is, the larger the width supposed to be. All right, so a minimum of 30 inches should be maintained before the equipment. All right, so the wider you want to maintain the same distance about equipment. All right, so the next one we're looking at is the height of the working space. The working space shall be cleared an extent from the floor or the platform to the height of 6.5 inches of the equipment, or a minimum of the height of the equipment, whichever is greater. All right, just we said the width, you should maintain the same in terms of the equipment, and if it's less, it should be at least 3 feet or 30 inches rather minimum. Right, so the equipment height, or the working space height for the equipment should be 6.5 inches, or the height of the equipment. All right, which one ever is greater. The next thing we're going to focus on all right, so we're still talking about the height of the equipment. All right, so this illustration gives us a clear understanding of the equipment height. So we're looking at the floor to 6.5 inches, or the height of the equipment, which one is greater. So equipment is 7 inches, then the height would have been 7 inches. 8 inches, height would have been 8 inches, right? Or a minimum of 6.5 inches, provided the equipment is not greater than that height. All right? So the next thing we're going to look at is the working space that's required in terms of space, in terms of voltage level at minimum 42 volts or 60 volts, right? Or 30 volts. So when it comes to low voltage source, it is not so required working space, all right? Because we consider working space due to the hazard associated with electrical equipment. So any voltage level that is very small, then we won't consider any need for working space, right? And any dead front assembly where there's no energized surface, then you're not looking for working space in that area. Think about why we had to push certain equipment to the back of a wall. because there's no energized surface probably to carry out maintenance on those equipment. All right. So where there's an energized surface, probably you have to maintain some space. And I can tell that minimum 30 inches is required. For non-energized area where you're gonna carry out maintenance. So typically there's no working space required for non-energized surface or dead front assembly. All right, so where access is required for non-electrical maintenance, at least 30 inches minimum should be maintained. That's what I mentioned there. All right, the next one I'm going to look at here is this clear space. Clear space is a space that you should have. So you have an electrical equipment established for maintenance, for inspection. You should have at least some clear space. All right, so you should have no obstruction before the equipment. In the event that these things are supposed to be done or carried out on the equipment. So you should always maintain a clear space for that sake. All right. So no storage is allowed for those areas. All right. So persons who have the habit of putting things in those position or place or in these areas, this is unacceptable. So we should always maintain clear space. Right? Next thing we're going to look at here is entrance and egression from working space. Now, there should be at least a minimum of one entrance, right? To allow entrance or egression from established working space about electrical equipment. Right? So any area using electrical equipment, you're supposed to have at least one exit or entrance in that space. Large equipment, 1200 amperes or more, 6 feet wide, that contain overcurrent devices, switching control devices shall maintain one entrance egression on both end, 6.5 feet or 24 inches wide. All right? So that's just a standard to say that larger equipment you should at least have you should have established rather two entrance on both sides. Right? So the larger equipment you're looking at least two entrance on both sides. 6.5 feet in height. All right, at least two entrance point there. And the dedicated equipment space. Next thing we're going to look at there is where we have the equipment, we need a space to lay it down. All right. So that is a space provided for the equipment. All right. So outdoor installation shall comply with 110.26. So installation requirements, outdoor electrical equipment shall be installed in suitable enclosure and shall be protected from the accidental contact with unauthorized person. Right? So any equipment outdoor, is supposed to be in an enclosure to protect it. Think about that. You have events of rain and other activities. So we have to have those equipment in an enclosure. All right. So the dedicated equipment space is needed where there's switchboard, switchgear panel board, motor control center, and it shall be located in a dedicated space and protected from damage. All right. Indoor equipment may also need a dedicated electrical or equipment space. All right. So where there's indoor installation, we're looking at equipment space, but we also need to facilitate piping, and we need to facilitate cables that come into that space. All right. So dedicated electrical space as a part of what we look for in terms of electrical pipes or cables. That's a measure of the height of the equipment or 6 feet above the equipment, whichever is greater. And it extends from the floor to the height of the equipment or the top of the equipment, or and should not extend beyond 6 feet. All right, so whichever is lesser. So typically goes to the height of the ceiling or less. Any foreign object above an electrical equipment should be protected from any breakage. Typically, we have pipes that goes through electrical space, and those pipes may subject to leaking. So we need to provide some amount of protection for those for the equipment. All right. So any sprinkler pipe, there should be protection to prevent any incident where breakage or leakage may occur in the electrical space above the electrical equipment. All right, so the space above and below the equipment are considered also electrical space. Right? So above the equipment, it should be at least six feet or less. All right? So if the ceiling is less than 6 feet, then it should take at least the height from the equipment to the ceiling. So that is how we look at, we put it in context in terms of adequate electrical space that should be made available for the equipment. All right, so every equipment may requires some protection, right? So the enclosure provides a means to protect the equipment from the external atmosphere. Right? So remember we talk about having at least one single entrance and egression from the working space. So this is what we're really talking about. All right? Having the necessary enclosure protection for the equipment. All right, so as we said, equipment enclosure and room requires to be locked to prevent unauthorized access. So personnel who would have the authority to go and service or inspect and maintain equipment. They are the only persons who are supposed to have the power or the access rather to those enclosure. Right? So we can't expect just anyone to go in there and just have access to the equipment or to provide inspections or maintenance. Right? So it's only authorized personnel should have access. And next one we're going to look at is illumination about working space. Now, illumination is required to have adequate visibility. This includes having sufficient lighting up over the space where the maintenance or inspection is going to take place. All right. So the next thing we're going to talk about, if there's multiple equipment next to each other and lighting is sufficient to extend beyond the other equipment, then we don't need additional lightings. Right? So additional lighting receptacles shall not be required where the workspace is illuminated by adjacent lighting source. Right? So the illumination is required for the working space in the case there's switchboard, switch gears, panel boards, motor control centers. And this is basically what it looks like. Right? So even have a multiple assembly of electrical switchboards and they're next to each other. Perhaps, lighting can be shared in between equipment, right? So you don't need a whole range of, lighting fixture, a whole lot run in one space. So understand that it can be shared in between equipment. So that is our presentation on spaces about electrical equipment. Okay, guys, just give us likes and subscribe to our platform. It was nice to share this presentation once again. All right. So we are trying to get as many subscribers so we can continue to do our work, to educate a lot of people on this platform. Right. So we're trying to grow our subscribers to 1,000. Right. So continue. Do whatever it is to subscribe to our platform and go to our website, join the engineering community. Right. Well, I'm going to spend some time to show you the same things that we share on this video on our platform. Right, so I wanted to go to the Visual Society of Engineers so you can see some of those things that we just talk about in terms of the article on the National Electrical Code. All right, so as I'm saying, one person to log on to our network or into your platform. We are trying to build, as many subscribers as possible, or get as many subscribers on our platform so we can continue to grow our channel. All right. So we're not able to explain everything based upon some aspect of the article. You can follow up with us on the website www.vigilantesocietyofengineers.com. All right, so I'm going to point you now to Vigilant Society of Engineers. And I'll be going through at least, some are showing, giving you some demonstration there, how you sign on to our platform, right? So our website is very user friendly and it makes it quite easily for person to access information, right? So I'm just going to share with you, the kind of say information that we share on this platform. All right, so our platform makes it quite accessible for persons who operate within the electrical field. All right, so we don't make it, very difficult. We just want person to really log on to our platform and get involved in our online, discussion or dialogue. Right? So it's very straightforward and easy to use, And first thing we want to make you know how to use the engineering community, right? Because that's where all the conversation is going to take place. That's where all the dialogues and interaction between, engineers and technicians and electricians and all those who operate in our areas. Right? So I'm just going to share my screen with you so you can see the website and how we designed it, and or you can get onto the engineering communities to have regular conversation, dialogues, engineers in the field. So we're going to show you like the articles, even the one that I just was explaining with you. And I'm going to show you how to get onto the engineering community, which is my #1 priority. All right, so you can get a chance to be a part of our online discussions and conversation. All right, so just a moment, please. So this is how it looks like, the Vigilant Society of Engineers. All right, so I want you to, take a chance, go through. You can look at articles on power system, motor controls, or motor construction and designs, grounding and bonding, electrical protections, space about electrical equipment, electrical load calculations, energy management, and so forth. Right? So we have a whole list of articles that is quite helpful for persons who are operating within the electrical field. So if you need to understand something about like power systems, integration, this is one of the best things. Right? You can go to these articles. We show you how to install renewable systems, and we show you how to govern the article. I mean, how to utilize the article in doing so. Right? Photo PV system, or you call it solar PV systems, and we show you how integration process works using these kind of systems. They want to take in your system. So the first disconnect means utilizing the required protection in terms of fuse or breaker in process to protect your systems. All right. So just understand how it works, right? So our platform quite make it easy for you to really be a part of online discussion, and also to understand the whole idea of going about applying electrical codes. Right? So we talk about breaker, labelings, after say we install in renewable systems into your traditional utility system. So any system coming from one system, or any system being powered independently should be identified within the distribution. So you must be able to identify the power that is supplied from the utility and the power that is supplied from a renewable system. All right. So we need labeling in that process. Right. So We can go further to explain, in details how it works. But integration is just a part of understanding how to put together two different power sources and understand, being knowledgeable of what the outcome might be, right? So, say for example, we talk about labeling the source coming from the renewable side, or the labeling that is coming from the PVC system or the wind power system, right? You must understand what you get in terms of the wave formation, voltage, or frequency, right? So system coming from the PV versus the wind power, windmill system, the frequency is going to be a bit different, right? So that may requires an understanding that there's modulation of the signal that should be performed in order to have the right um, frequency, right? So integration process can take place, because it would have been a catastrophe knowing that you have different signal coming in and then you're trying to integrate them. So that is why you utilize utility interactive inverter in that process, right? So understanding the whole concept of interconnected system is so important that you have proper integration with the utility system. All right. Next thing we're gonna look at here. Next thing we're gonna look at is our motor. We can look at motor system. So if you want to really understand a bit more about electrical motors, you can, read up on it as well on our website. Right? So we talk about the principal operation of electrical motors, the construction of paired or pole paired, or the construction of the motor. Rather, we talk about pole pair, but in truth, there's really the sub concept behind the motor construction. All right. So looking at this demonstration, you can see how the poles are actually, paired. Right. So you have the stator winding and you have the rotor windings. Right. So the stator will have to be coupled with the rotor. But we can go further to explain how this process works. All right. So what we're saying is that the construction of the motor is actually is designed in such a way that there's actually polarity, right, between the stator and the rotor. Right. So in the process though, with this kind of motor, right, fundamentally we have to understand that within the types of motor, there might be different, designs. Say this motor here is a split ring, or a slip ring, they call it, slip ring rotor, or some people say a squirrel cage rotor, right? Now, in the squirrel cage rotor, there's like actually a cage of metal bar, and then you have on the stator, which is coils, and then now when the current flows within the stator, it induces the current or the field within the rotor. All right. So this is like a unique design only for induction type motor. So we can talk about the stator is responsible to deliver power to the motor. The slots on the periphery distributed the coil and form the pure pole and hold the core and the frame to the foundation. All right. So the rotor is a cylindrically formed, rather it is cylindrically formed and have slots on its periphery. All right. So what does that mean? Remember, I just mentioned that way it's designed in a cage form, right? And it, though it says it has the slots on its peripheries, that's it. Though it may it it looks pretty solid. Looking at the diagram here, right? It's solidly formed, but those metal bars, they're really formed within the thick, the core of this metal here, right? So those are fitted within a slot within the core of the rotor. So the conductor is formed from the aluminum, brass, or copper bars. All right. And the conductor is placed in the slot and enclosed by the end rings. So within the bar, there's like a diagonal slots within the core of the rotor, and then there's like a ring in between the bars. That's how the motor is basically constructed for, this type of, or in this version of the induction type, right? So the concept really can applies generally to all motor, right? But this motor we're talking about here is a kind of motor, or say an induction type motor, right? So induction type motor uses only like a slip ring, which is cylindrically formed. It has no windings, but it uses a process we call electromagnetic induction. That's why we refer to it as an induction type motor, right? And it uses the frequency to create the rotation. That frequency is generated through the stator, right? So it's at a rotational, when there's a rotational field that is generated in a stator winding, it induces the power within the rotor. And within the rotor, you're going to have current. And once there's a current, there's going to be a field. So when there's a field created between the stator and the rotor, you're going to have rotation between the stator and the rotor. So any such interaction between the stator windings and the rotor winding will cause a rotation of the rotor, right? When the rotors, or when the field from the stator is rotated, then the rotor is going to rotate with it. That is referred to as a synchronous. This rotation is synchronous, right? Because it moves at the speed of the stator. So when the field rotates at a synchronous speed, the rotor actually will move at the same, relatively the same speed, right? The speed that is lost is referred to as a slip, right? The slip speed, right? So there's some amount of like slip between the stator and a rotor. So we're gonna have to, so going forward, we understand whole concept between induction type motor. This principle may not apply. I will talk about synchronous speed or the principle of electromagnetic induction. Doesn't apply to every types of motor. Reason why? Because some motor are directly wounded onto the rotor. There's actually windings on the rotor, and those windings are connected through they call it a slip ring, right? A slip ring or they call it rather it's a slip ring or a split ring rather, and then we have what we call a commutator. All right, so the power will deliver to that part of the motor to deliver to the rotor. All right, so that's a direct connection between the power that drives the motor. It drives both the stator winding and the rotor windings. All right, so this motor is a different motor though. This one is an induction type motor that it has no direct connection. But anyway, guys, I just want to highlight some articles that we have on our platform. We can also talk about electrical grounding or bonding, or electrical, yes, grounding and bonding. So you understand the whole concept of grounding, right? The reason why we provide grounds and the reason why we need it for protection purpose, right? So you have earthing, earthing are grounding and all those things, which are also a part of electrical protection, right? So when you have lightning strike and this excessive energy that comes to create damage to our electronic equipment and so forth, you can use like earth rods or lighting rods to actually channel the energy in one particular direction. So it serves multiple purpose, right? So we can go on and on in terms of our articles and so on, right? And how we use the effective grounding part to actually de-energize equipment, prevent electrical hazards. Right? So we have other articles here like electrical protections, right? So electrical protections as it is protect equipment, right? From over voltage, over current, over overload condition, etc. Right? That include transformer, breakers, and feeder taps and so forth. Right? The appliances, and it goes on. Right? So this is what I want to look at now. How we get into the engineering community. Right? So the engineering community is pretty much what we are encouraging persons to get onto. All right, so we're looking at way how we access engineering communities. Right? So our engineering communities are pretty much the place where all interaction and dialogue would normally access will able to take place. All right, so joining the community is pretty easy. You can go here and we have the about section and then select engineering community. All right, and then this is where it takes us on the page on our website. And look, you need three things, right? Tell us about you, your specialty, why you want to become a part of the engineer community, and what are your hopes for the future. All right, so that's pretty much a part of building your profile. Understand? So building your profile is just about mm, giving us more detail about yourself. All right. Next thing we'll talk about is joining the group. You know, some persons may be technicians, some persons are electricians, some persons are engineers. Right? So you need to join our group and so forth. So joining our group is basically assigning yourself or joining a group or group, you know, is a part of identifying, you know, which area you actually partake in, right? So it doesn't matter if you identify yourself as an electrician or a technician, you know, you're a part of one group, right? But then where a person may have their specialty, of course, you have to identify those individuals. So joining the group, you know, it will make you be a part of the whole community. But then we have special groups, meaning you have to select, you know, those people who are working in your area, right? So the field can go a little intricate, or it goes more in detail in terms of identify individuals, because you have instrumentation technicians and communications technicians or engineers or electricians and persons who operate in power systems. All right. But then once you go on and join, then you have to be a part of one group. And you'll see conversation across groups. So it doesn't really matter. Right? And we're just asking for one thing, the persons will attend our presentations, webinars, and so on a regular basis. Right? That is not much we're asking for. So as you do, get onto the platform, you need to rather select signed up. So when you select sign up, it will take you to another, well, this is a part of, this is our community really. Extend to this group. I said join the group. Now, all right. So you're going to have to enter, you know, or log in using your Gmail account or Facebook. Maybe this is Yahoo email. All right. So you can use login Google. I use that one, and then I select, you know, my account on Google, and that will take us to engineering group. This is where you can see all of what we've been doing. So I'll be blogging about stuff on electronics. I also a post on commercial electrical installation, residential apartment, you know, and so forth. Right. So we encourage persons to go online and, you know, share as much as they can share on the engineering platform. Right. So we are about community. We are about sharing our ideas and knowledge in the field. There's a lot of persons will have the same interests as I do in some areas, right? And even so in other areas that they don't have great understanding in, which they also want to gain much knowledge, right? So I would encourage, you know, person to come on board and, you know, be a part of um, our conversation, our discussion. This is like one presentation I've done. And we're doing a lot of these things. So I would encourage person to join our platform and be a part of the conversation. There's so much thing you can learn. All right. So don't be shied away from what we're about to share. There's a lot more to gain than to lose in this process. All right? So we are quite a very informative platform that we wish to assist those who are really interested in the field or in the engineering discipline. Right? So this is just about it, and I want you to give us a like and subscribe to our YouTube channel, and make sure you join the engineering community. Right? That is more important than anything else. All right? So don't hesitate. Please go ahead, join our platform. Be a part of our live conversation or discussion. Right? So don't hesitate. Not gonna charge anybody as far as this is concerned. Because now we're growing our platform. We want more people to join, and we need more support. And as we go forward, we would involve more stuff and more activities for person to participate. But for now, we're doing live presentation, right, on various topic in terms of what we put out on our website, right? So if you don't get what we have provided on the YouTube channel, just follow up on the Vigilant Society of Engineers.com for more information, right? So the discipline that we covered will be in communication, power systems, and we talk about instrumentation system as well. Right? So don't be afraid. Just come on and log on to the Vigilant Society of Engineers. Right? So we can continue to host regular discussion in terms of this particular area. Right? So I'm very happy to bring to you this presentation. So I feel more or less, this is the best thing that I can do to actually bring to my contribution to the electrical field, right? So very happy, to be broadcasting our platform, and go ahead and subscribe to our channel and keep us posted, right? So join the engineering community, and while you join the engineering community, all right, just give us, post whatever you know or you want to share, and then we'll go and answer any questions or reply to those posts. All right? So I'm very happy to be sharing this kind of information with you guys, right? As I feel more or less more awareness need to be put out to the public so that they can know what we are doing and what we are trying to accomplish. All right, so go to the Vigilant Society of Engineers.com whenever you have the opportunity. Right, you can read on articles on grounded systems, motor systems, interconnected power systems, energy management, and so forth. Right. So if you want to really stay grounded within your field, just follow us, right, on YouTube. We'll be giving you the feeds in Facebook as well, and join the engineering community, be a part of our conversation. Now, guys, I'll be logging out, and I just wanted to continue to support us in our venture. All right, so I'll say good night for now, and stay tuned for another presentation. All right, so thank you.